We've all been there, you know? You're standing in front of some particularly nasty cleaning challenge, maybe a stubborn grout line or a greasy oven, and that feeling just hits you, that impatience. You think, I need to get this done fast. And then if my cleaner is good, why not just add a splash of something else to, really turbocharge the effort?
And that exact impulse, that drive for maximum efficiency and power,
Yeah.
that is what leads to some of the most common and, frankly, terrifying chemical accidents in the home.
Right.
So today we were talking about that our mission today is pretty simple, really. It's to rapidly synthesize the life-saving chemical knowledge that's kind of hidden in plain sight, right in your cleaning cabinet.
Okay.
We need to analyze what happens when these two things meet, what the resulting toxic gases do to your body, and most importantly, the non-negotiable steps you have to take if you ever make this mistake.
All right, so let's unpack the motive here, this accidental experiment. The person in our source material, they'd already been using chlorine bleach for sanitizing.
The go-to for tough jobs.
Exactly. But then they decided, a little boost was needed, and I find this so relatable. They thought, ammonia is great for grime. I'll just add a splash to make the cleaning stronger.
And that right there, that is the core misunderstanding. You're looking at these things as just cleaning tools.
Right, not as chemical.
Not as highly volatile chemical compounds. Bleach is a powerful oxidizer. It's fantastic for germs and whitening. Ammonia is brilliant for breaking down fats and grease.
So it makes sense intuitively.
It feels like you're creating a super cleaner, sure, but what you're actually creating is what the source material correctly calls a disaster without knowing it.
Because you're not just adding soap to soap, you're forcing two high-energy reactants to interact with each other.
Exactly.
And that leads us straight into the chemistry of, lethal gases.
Precisely. To really get the danger, we have to call the components by their proper names.
Yeah.
The liquid we all call bleach that contains sodium hypochlorite, its formula is NaClO.
NaCl, got it.
And the active ingredient in most of those household ammonia solutions is, of course, ammonia or NH3.
So when NaClO meets NH3, what actually happens on an atomic level? What starts the clock?
It's a rapid chemical substitution reaction. The sodium hypochlorite essentially starts stripping the hydrogen atoms off the ammonia molecule, which forces a complete rearrangement of the atoms. And this process produces brand new, highly toxic compounds that are known collectively as chloramines.
Chloramines. Okay, we hear that name, but for someone listening who just sees a cloud of fumes, what makes them so much more dangerous than, say, fumes from a regular industrial cleaner?
But the danger is insidious, and it's physiological. Chloramines are extremely reactive, so when you inhale them, they immediately find moisture.
And there's moisture everywhere inside you.
Everywhere. The lining of your eyes, your nose, your throat, and critically, the moist tissue deep inside your lungs.
And when a chloramine molecule meets that moisture, what happens?
It hydrolyzes. It breaks down into various highly corrosive compounds, including types of hydrochloric acid.
Wait, so you're saying you are literally generating corrosive acid inside your respiratory system?
That is exactly what's happening, and that causes immediate burning pain. But the real long-term danger is that corrosive action makes the delicate tissue in your lungs swell up.
Oh, wow.
And that leads to fluid buildup, a condition called pulmonary edema.
That sounds like you're suffocating on dry land, like your own body is flooding your airways to fight a chemical burn.
That's a perfect analogy. It inhibits your ability to transfer oxygen into the blood, and it very quickly begins to starve your organs.
Yeah.
But here's where it gets even more alarming.
Okay.
This is where we get to that chemical weapon tone from our source material.
You're talking about elemental chlorine gas?
Yes. Chloramines are the most common toxic output.
Okay.
But if you're using large quantities or if the mix generates enough heat,
So a really vigorous reaction.
a really vigorous reaction, yes, that heat and concentration can actually break down the chloramines further, releasing chlorine gas itself, Cl2.
And that's the historical chemical agent, the gas from World War I.
It is. The chemical equation shows it. Under certain conditions, the chloramines decompose and they free the elemental chlorine. So, depending on how much you mix, you're either making highly corrosive chloramines or, worst case scenario, you're making a concentration of Cl2 gas that is powerful enough to incapacitate you in minutes.
And that's the transition people miss, isn't it? They think they just mixed a couple of smelly cleaners. Not that they've tipped the balance from a localized lung irritant to something, far more lethal.
And this raises a really crucial practical question. Is this danger only there if you mix industrial strength versions? Or does this apply to the stuff under our sinks?
That's a great question. And based on the source, the danger is absolutely present, even with standard household concentrations. The key isn't necessarily the strength of the product you buy. It's the quantity you mix together, especially in an enclosed space.
Right. And speaking of enclosed spaces, when this terrible chemical experiment starts, people often don't realize what they've done until the physical symptoms start hitting them hard.
Yeah.
What should someone be watching out for?
Well, the danger is just, it's so much worse if the area is enclosed. Like a small bathroom with no ventilation, which is always the target for a turbo clean.
Always.
The symptoms are almost always immediate and deeply distressing because the gas is attacking your mucosal membranes directly.
So the very first thing you'll probably notice is a rapid, intense burning sensation in your eyes. Maybe your nose and throat, too.
Right. That's the corrosive action happening in real time.
Exactly. It's the gas reacting with the moisture on those surfaces.
And after that, the respiratory system just goes into crisis mode.
Absolutely. You'll feel a shortness of breath. It's often described as like a tightening or a constriction in your chest. That's your airways swelling shut.
And that would be followed by a cough, I'd imagine.
A strong, relentless, persistent cough is your body trying desperately to expel the corrosive agents.
I imagine panic just sets in so quickly at that point.
It does. And as your ability to get oxygen drops because of the swelling and the chemical burn, 2 other major symptoms pop up. Severe dizziness, and then very quickly, potentially fainting. Loss of consciousness.
And if you faint in the room with the gas?
The exposure time increases exponentially, and the outcome there is often fatal.
So, if you're cleaning, you smell that incredibly strong, irritating odor and you start coughing almost instantly. You do not have time to debate what you did wrong. You have minutes, maybe seconds, to start the escape plan. Which brings us to the most important part of this deep dive, the safety protocol. What is the immediate, non-negotiable first step?
The crucial step is to recognize the danger and prioritize getting out over everything else. The instruction has to be drilled into everyone. Ventilation, ventilation, ventilation.
And we're not just talking about cracking a window here. We're talking maximum air exchange.
Maximum air exchange, minimum personal exposure. That's the goal. You have to open every window and every door you can to create a through draft, and you exit the area immediately.
Don't linger.
Do not linger. Don't try to save the cleaning solution. And please, do not try to hold your breath and stay inside to clean up the spill.
Why is just abandoning it so critical?
Because the chloramines and the chlorine gas, they are significantly denser. They're heavier than the air you breathe.
So they sink.
They sink. They will rapidly accumulate near the floor and on surfaces. If you try to lean over to wipe up the spill, you're just guaranteeing a higher concentration of exposure right near your face.
Right, where you breathe.
Exactly. Your only goal is to get out fast and make sure the area is ventilating. Once you're out, get to fresh air, and if symptoms persist or get worse, call emergency services right away.
So you leave the mess, you save your lungs. That's the only equation that matters. Okay, so let's distill all this complex chemistry down. What's the one golden rule?
It's the definitive safety instruction, and it really should be tattooed on the inside of every cleaning product label out there. Bleach should never be mixed with anything except plain water.
Never.
Never.
I want to circle back on that for a second because sometimes ammonia isn't explicitly listed on a label, right? What about things like window cleaners or some degreasers that might contain it? Does the danger still apply?
That is a very, very smart and practical question. And the answer is yes. While, highly dilute or trace amounts might produce a less vigorous reaction, the danger is still absolutely present. The safest rule is this. If you're using bleach, you use only bleach and water.
And if you need another cleaner?
If you need to use a different chemical product, even something as simple as glass cleaner, you have to thoroughly rinse and ventilate the area between applications.
To avoid any cross-contamination.
Exactly. Never, ever assume that just because a label doesn't shout ammonia at you, that it's safe to mix with bleach.
That really clarifies the level of caution we need. So we've basically turned the simple desire for a stronger clean into an understanding of an atomic rearrangement that creates lethal chloramines.
And in high concentrations, weaponized chlorine gas.
Yeah.
And what we hope you realize from this is that understanding the building blocks, the sodium hypochlorite, the NaClO, plus the ammonia NH3, it gives you life-saving knowledge that's so much more valuable than just reading a warning sticker.
Because you understand the mechanism of the disaster.
You understand the why.
So what does this all mean for your routine going forward? We've looked at one specific interaction, bleach and ammonia, but this whole process of mixing cleaners, the search for the super cleaner, it's incredibly common.
It is. So our final provocation for you to mull over is this. How many other common, seemingly benign household chemicals might be hiding equally dangerous, volatile interactions?
For instance, what happens when bleach meets strong acids, like vinegar or certain toilet bowl cleaners?
Exactly. What is the true cost, not in dollars, but in personal safety, of prioritizing speed or strength over taking 5 seconds to actually read the chemical composition on the back of the bottle?
The takeaway is clear. From now on, critically read the labels of all your cleaning products. You might just be saving your own life.
Or someone else's?